We are recording now. Okay.
Uno, de ahí,
Voy a hacer la presentación y voy a luego de la presentación salimos, ¿ok? Espera un momentito. Okay. Good evening, Professor Narayan. Good evening, Professor Pita Charan from India. We are so glad to have you in this special lecture. There are many students of the different levels that will stay now in your class. We are very excited with the knowledge that you can share with us. Now is the Professor Ulises, who is coordinator of the research group of information technology and data science. So we will do the introduction to your presentation to start your lecture. Okay. ¿Puedes empezar a hacer la introducción, Ulises, del profesor?
ok. Buenos días, distinguidos invitados. El día de hoy vamos a dar inicio a una jornada académica organizada por el Grupo de Investigación y Data y el Decanato. Your translation, Ciro.
Sí, el día de hoy vamos, today we will start very special sessions of machine learning with Professor Narayan.
Para nosotros es un honor tenerlo aquí para la capacitación del curso Introducción a Machine Learning y sesiones de prácticas con Python.
For us, it's an honor to have you in these lectures to share your knowledge with all the students that are very interested and with expectations.
Estamos seguros de que este curso de introducción de Machine Learning va a ser de provecho para los estudiantes y docentes que tienen interés en el área temática.
We are sure this course will be successful for students and professors that have high interest in the machine learning.
De hecho, nosotros como grupo de investigación trabajamos en el área de Data Science, Machine Learning, Business Intelligence y Data Mining.
The group is working with data science, machine learning, and data mining.
Entonces, vamos a dar inicio. Quiero presentar al doctor Narayan. Él es miembro vitalicio de la IEEE, senior y decano de investigación y desarrollo y profesor del Departamento de Ingeniería Eléctrica e Informática del Saint Vian Institute of Technology, Bangalore, la India. Zero your presentation, Dr. Narayan. Ernesto, ¿se escucha?
Sí, correcto.
Ernesto,
Sí, ahí sí.
puedes comunicar al doctor Narayan que estamos, le agradecemos por su presencia y estar acá en la Universidad Nacional Mayor.
Okay, Dr. Narayan, we thank you a lot for your presence here and thank you for your support to this lecture.
May I start presenting?
So, quiero saber si ya puede comenzar a presentar.
A ver, un momentito, vamos.
Yes, Professor Narayan, you can start your presentation, please.
Ok, puede iniciar el profesor Narayan, Ernesto.
Doctor, perfect, you can start.
Yeah, good morning to one and all who are present in Peru, and good evening to one and all who are present in India. I thank Professor Siru and Professor Nobata who have introduced me. Thank you so much for giving this opportunity. I also thank Dr. Rita Sharan from Oxford College of Engineering, India, to have introduced me for this wonderful program. I thank all the organizers and the students who are present at this particular session and this course on Introduction to Machine Learning and hands-on session to Python programming language. Thank you very much. I'll be showing the English as well as the Spanish version of the slides side by side, so that it will be easy for the people to understand and will be able to follow. So we can overcome this language barrier, and I should really thank Professor Siru for converting into Spanish language my presentation slides. Some minor changes I have made in the presentation slides. Anyway, that will not matter. So thank you once again for inviting me and for a wonderful introduction. So myself, Dr. Narayan, I come from Sai Vidya Institute of Technology, Bangalore. It is in India, and I have done my doctorate from Indian Institute of Science, Bangalore, which is a quite famous institution in the world. And all of us right now are in a pandemic situation, and really this online mode has helped us in learning the subjects and many things. So I hope with God's grace we'll come out of this pandemic sooner than later, and we'll be able to see each other physically soon. That is my intention. Maybe I can visit Peru, or you people can come over to India. With these few words, I'll be starting today's session. Already Professor Noboto has introduced me, so I will not be going into details of this. My research profiles and other things are known. I'm quite active in social media, so anybody who wants to follow my post on machine learning and so many other topics are mentioned here, you can go through that. So these are the topics to be covered. What is machine learning? This is not converted into Spanish, so I'll just read out in English, then I will show you the appropriate Spanish slides. So what is machine learning? Examples of machine learning implementation. What is artificial intelligence, machine learning, and deep learning? How are these terms interrelated? Significance of statistics, vector algebra, scalar and dot products, matrices in machine learning, overview of Python packages, NumPy, scikit-learn, TensorFlow, Keras, plotting functions, Matlab, and Seaborn, types of machine learning systems, main challenges of machine learning, best way to learn machine learning, then a couple of hands-on sessions, Titanic machine learning project. See, I've just shared this in your Google Classroom and also with the professor. In this hands-on session, we'll be seeing how the goal is to predict whether a passenger has survived based on attributes such as his age, sex, passenger class, where they were embarked on, and so on and so forth. And how the data set is shared, and guided hands-on sessions will be implemented using Google Colab, which is a free source software which is available, and coding a simple chatbot is also part of this one, time permitting. So let us go on with what is machine learning. Introduction to machine learning. So what is machine learning? A computer program is said to learn from experience with respect to some class of task T, and the performance measure T if it is performance at task in T as measured by P improves with the experience E. So this is what is the so what to say, as told by Tom Mitchell, what is the definition of machine learning? A computer program is said to learn from experience E with respect to some class of task T and performance P if its performance is a task in T as measured by P improves with respect to E. This is what is the definition which is given by Tom Mitchell in 1959. Machine learning is a field of study that gives computer the ability to learn without being explicitly programmed. So this is very nice definition which is given by author Samuel in 1959. Machine learning is the field of study that gives computer the ability to learn without being explicitly programmed. So if the computer is able to learn on its own without being programmed, that is what is machine learning as told by Arthur Samuel in 1959. So all these definitions have come way back in 1959, and we are trying to implement that in the year 2020 and 21. So I'll just show you the appropriate Spanish slides for a few minutes for the people who are well versed with Spanish language to understand what I am trying to tell you. So what is machine learning? So this is what it is. Just showing you the appropriate Spanish slide so that the people who are comfortable with Spanish language can understand this. Fine. With the understanding of definition of machine learning, we'll go forward. So computer has to learn without being programmed. So this is the basic concept, very easy to understand this definition. With this few words on understanding the definition, we are going next. Now, just one example of machine learning. You get a lot of emails in your mailbox, and many of us will get hundreds of emails in a day. Many even go into thousands of emails, so depending upon the organization and the type of work that you do. So these mails are the input to the machine learning system, and this can be either classified as a spam email or regular email in your using your machine learning algorithm. So this is the simplest example I can give of machine learning implementation, where your emails can be classified either as a spam mail or a regular mail based on the machine learning algorithm. So this is the classification problems. I'll just show you the appropriate Spanish slide. So there is nothing here. So this is an example of machine learning, spam versus regular mail. So that is the input to the machine learning algorithm systems. So it is either classified as spam email or regular email. So this is what we are trying to understand here. So this is the simplest example of a implementation of a machine learning algorithm. So if this is implemented, you are searching through the various emails which are spam and deleting them or putting into spam folder will be reduced. Anyway, it is already being done by Google. Okay. Okay. This is another example of machine learning implementation. Here, what we are trying to do is the word translation in Mathematica. So this I've used one software known as Mathematica, where I have translated the word Spanish into your language. Spanish is translated into Spanish language. So the input word translation in Mathematica machine input for the word translation. So this is a language in Spanish. So that is show again given in Spanish language, and the word translation of poetry in Spanish is again translated. This is the output from Wolfram Mathematica. Is the example that I have taken, an example of machine learning implementation. Okay. So again, I have just showing you in the Spanish language for you to understand that better. The language Spanish, how it is translated into Spanish, and the word poetry, how it is translated into Spanish using machine learning algorithm. Okay. This is another example of machine learning algorithm where we are going for image identification or image classification. So now here machine learning input for image identification. So this image is of a dog. So image identified. This is a dog. So what breed of dog? Hound. So that is the output. So yeah, this is the input. So I'm just giving the photo to the or the picture to the machine learning algorithm, and it is also giving the attributes of the not only the dog, the type of the dog, hound in this case is what is the output I receive. So here in the second example, what I am giving, the data is a car. Okay, so this has a okay, so this is what it has to identify. So what are the various attributes I will end up understanding from this picture? So this machine learning algorithm is should do, that is a convertible, whether it is a cruiser, whether it is a coupe, whether it is a saloon, whether it is a limousine. So you get here the probability here. See, I have a attribute here, probability. So for a convertible, the probability is 0.37, and for a cruiser, the probability is 0.371206, and for a coupe, the probability is 0.098, and for a saloon it is 0.076, for a limousine, station wagon. So when I give an image of a car, so this machine learning should tell me whether it is a convertible, whether it is a coupe, whether it is a cruiser, a hatchback, a cab, an automobile. So for an automobile, this probability is almost 1, that is 100%. It is definitely an automobile, it is not a bullock cart. So if I put a bullock cart here, at least this automobile should come as a 0 here. So instead I'm getting 1, that means my machine learning algorithm is predicting that this is a car, at least in the car. So what is the type of the car, whether it is a cab, whether it is a hatchback, whether it is a station wagon, whether it is a limousine, whether it is a saloon, whether it is a coupe, whether it is a cruiser, whether it is a convertible, is what this machine learning algorithm has to predict using this image identification of whatever is the input that is provided. So with this, what we can understand is the probability, or from this output, what we can understand is the probability of this image being car is almost 1, that is 999.99, that is almost 100% probability that this image what I am inputting is the automobile, and it can be either be a cruiser or a convertible based on this machine learning algorithm that what we have designed. Whereas the probability of it being a coupe, it is just 1%. 9%, saloon it is 7%, limousine if I multiply into 100, this will be 3%, station wagon 3%, and hatchback 0.6%, cab is very less. So machine learning will tell me this is an automobile 100%, it is a convertible, or it is a cruiser. So this is what is a machine learning input as an image, and output I will get what is that image. So this is what my machine learning algorithm will do. So I'll just show you the appropriate Spanish slide for you to get better understanding. This is the image classification problem in machine learning. I hope you are understanding or following the basic introduction of what is machine learning, and we can go forward from here.
Indico que si todo quedó claro, podemos seguir avanzando.
Ernesto pregunta si hay alguna pregunta.
Yes, please. Yes.
¿Alguien que quiere preguntar? Ernesto hace su traslado.
No, todavía, hasta el final son las preguntas. Al final.
Okay.
Okay, doctor, you can proceed.
Yeah.
Questions will be at the end.
Okay. I'll continue for another 45 minutes, then we can pause for the question answer and for session for today.
Perfect.
So the next question what arises is, what is artificial intelligence, machine learning, and deep learning? So these are the various terminologies which you will be bombarded nowadays in any of the where you go, whether throughout the world. These are the buzzwords which are going: artificial intelligence, machine learning, and deep learning. And many courses are being designed on this, because this is what is going to be the driver growth for the technology at this era. So that is why we are here learning this subject, trying to understand what is machine learning and how are these terms interrelated. So this is what we're trying to do. So you have a broad area here you can see as a data science. Okay, under data science you have artificial intelligence, machine learning, and deep learning. So yeah, data science will encompass everything. Under data science you have artificial intelligence, and machine learning being a subset of that artificial intelligence, and deep learning being another subset of the machine learning. So this is what we'll be able we are trying to understand right now. Okay, this is the appropriate Spanish slide for the people who are conversant with Spanish language to see that. So in data science, you have artificial intelligence, machine learning, and deep learning. So machine learning is a subset of artificial intelligence, deep learning being a subset of machine learning, and data science encompasses everything. So what is the difference between that? We'll be trying to understand in this slide. Okay. Having understood, we have something known as data science. Then we have something known as artificial intelligence. We have something known as machine learning, and we have something known as deep learning. So how are these terms interrelated is what we are trying to understand here: artificial intelligence, machine learning, and deep learning. So how are these terms interrelated? How are the terms artificial intelligence, machine learning, and deep learning interrelated? How are the terms artificial intelligence, machine learning, deep learning, how are these interrelated is what we are trying to understand in this particular slide. Artificial intelligence is concerned with the design. Artificial intelligence concerned with the design of intelligence in an artificial device, the study of computations that make it possible to perceive, reason, and act. So once again, I will tell: artificial intelligence concerned with the design of intelligence in an artificial device, the study of computations that make it possible to perceive, reason, and act. So this example was given by Winston in 1992. So I'll show you the appropriate slide for artificial intelligence. This is the definition of artificial intelligence, which was given by Winston in the year 1992. This is the Spanish interpretation of the English statements, study of the computation that makes it possible to perceive, reason, reason, and act. Perceive means you have to find out something. See, what does a human being do? Perceive. See, for perception means, see, in the night, you want to drink water, so you touch a water bottle. You know it is a water bottle by just touching it. You don't have to have an image classification of that. Then yeah, your mind will reason you that is a water bottle and you can drink it. So then you will act. What is the action you will take is you will remove the cap of the water bottle and you will drink it. So that is what is perception. In this case, the perception is your brain will know the contour of the water bottle, that it is a water bottle. Then it will reason it, the perception, then it will reason, oh, okay, it is a water bottle. Then you will open and drink it. So you won't see it with your eyes, put a light whether it is water bottle or not. If you only get a doubt, you do that. So that perception, reasoning, and acting is what human being will do, and the same thing a machine learning should do. Artificial intelligence should do. So this is the definition which was given by Winston in the year 1992. Okay. So having understood what is artificial intelligence, now, machine learning, as we have seen in the previous slide, is a subset of artificial intelligence. As we have seen in the previous slide, machine learning is a subset of artificial intelligence. Subset of artificial intelligence is a study. Machine learning is a study that gives the computers ability to learn without being explicitly programmed. Again, this was shown in the beginning slide also, by Arthur Samuel in the year 1959. So machine learning is a field of study that gives the computers the ability to learn without being explicitly programmed. So the computers will have the ability to learn. So machine learning gives the computer the ability to learn without being explicitly programmed. So that is what Arthur Samuel did in the year 1959. So that is what is this one. So ability of the computer to learn without being explicitly programmed. Okay, deep learning. Okay, now we have one more term here known as deep learning. So artificial neural network at the core is a deep neural network. An artificial neural network with a deep stack of hidden layers is called a deep neural network. So in deep learning is more complex than the first two. So again, I'll go back to this slide. Machine learning, which is a subset of artificial intelligence, and deep learning, which is another subset of your artificial intelligence. So artificial intelligence encompasses everything. Machine learning as well as the deep learning, it encompasses everything, and your data science will encompass everything. So artificial intelligence is a more general thing where you have to perceive, reason, and act, and the computers will learn independently without being explicitly programmed. So that is your machine learning. And your deep learning is the artificial neural network with deep neural network. The artificial neural network at the core is a deep neural network. That means you will have a lot of hidden layers in case of deep learning. That is, you use what is known as a convolutional neural network and many other things where you have so many hidden layers for deep learning. So deep learning is not part of this course. I'm just giving an example of what is deep learning. So artificial neural networks at its core with many hidden layers is what we can term as a deep neural network, or also known as the deep learning. Artificial neural networks are at its core with many hidden layers is known as the deep learning. So all these are interrelated terms: artificial intelligence, machine learning, and deep learning. So deep learning is a subset of machine learning. Machine learning is a subset of artificial intelligence, which is again a subset of your data sciences. So all these are interrelated subjects. Okay. Now, very good. So next slide is artificial intelligence, machine learning, and deep learning. How are these terms interrelated? How are these terms interrelated? How are the terms artificial intelligence, machine learning, and deep learning? How are these terms interrelated? related is what we'll be understanding in this slide. So you can see here, this is a multi-layer perception problem. These figures are inspired from Aurelian Guérin. So you have an input layer, you have a hidden layer, and you have an output layer. So these are the two input variables x1 and x2, and you have the output layer here. This is a multi-layer perception problem, which can be seen as what analogous to your biological neural networks, where you have multiple layers in your human cortex. So this is your human cortex here. This is your biological neural network. That is what is the nervous system. If you have to take your brain and see the human cortex, how the human cortex will look like, this is how your biological neural network will look like. So you have so many hidden layers here. That is why your human brain is so complex. We can think multiple things, and God has designed in such a wonderful manner that if you have to mimic the human neural network in artificial intelligence, it is going to be a big challenge. And the number of hidden layers you can see, this is your biological neural network, and this is what we are trying to do in a multi-layer perception. This is your hidden layer, and this is your output layer. In your deep neural networks, you will have a lot of these hidden layers, whereas in a machine learning, you may just have one hidden layer. Whereas in a deep neural network or deep learning, what we have, we will have many hidden layers, and only one the number of hidden layers will go. This is only one in this case of machine learning. Whereas when your biological neural network, you will have so many hidden layers. So just to show you the example in Spanish. So you have so many hidden layers in biological neural network. This is actually what we'll try to implement in our deep neural network. Whereas in a machine learning, you have only one hidden layer and you have an output layer. So in your deep learning algorithm, you will have many of such hidden layers. That is what I wish to tell here. These figures are from Guérin. Okay. Okay. Artificial intelligence and machine learning and deep learning, how are these terms interrelated? I think you are able to see this. Data science is an interdisciplinary field which uses scientific methods, processes, algorithms, and systems for knowledge extraction and insights from both structured and unstructured data. Why it is there? So once again, I'll repeat. Artificial intelligence, machine learning, how are these interrelated? We are continuing with knowledge of interpreting the interrelation between artificial intelligence, machine learning, and deep learning. So data science is an interdisciplinary field which uses scientific methods, processes, algorithms, and systems for knowledge extraction and insights from both structured as well as unstructured data. Why it is there? Data is the primary element for all these areas: artificial intelligence, machine learning, and deep learning. For everything, you need a data set. So you have data science. So data science is common input for your artificial intelligence, machine learning, and deep learning. And we use complex algorithms, processes, depending upon what we are using. So again, there is one more. Statistics is a discipline that concerns with the collection and organization, analysis, and interpretation of the presentation of the data. Machine learning models are statistical. So after understanding what is data science, statistics is a discipline that concerns with the collection, organization, analysis, interpretation, and presentation of the data. And machine learning models are statistical and probabilistic model. So machine learning models are statistical and probabilistic model that capture in the data through the use of algorithm. So this is one example of scatter plotting using Python in Kaggle notebook. So this is example of a scatter plotting. Significance of statistics, vector algebra, matrices in machine learning. So we'll be using statistics, vector algebra, that is your scalar and dot product, and matrices in machine learning. So mathematics is very important if you want to understand machine learning, or for that matter, if you want to proceed towards deep learning. So you should have sufficient or significant knowledge of statistics, vector algebra, which has scalar and dot product, and matrices in machine learning. Just give me a second. So we are here. So 1 second, just my this one got stuck. I'll show you the appropriate slides in Spanish. So what is data science we have understood, and we have also understood the importance of statistics, vector algebra, and matrices, and its significance in machine learning. So if you want to understand machine learning in detail, so the basic understanding of statistics, linear algebra is very much required, and this is an example of scatter plot using Kaggle notebook of basic example of a machine learning. So significance of statistics, vector algebra, and dot product and matrices in machine learning. Since all the data is not only numerical, it has to be appropriately converted into a numerical representation which is fed to a program. So data are considered as vector. So now I am trying to explain you the significance of statistics, vector algebra, scalar and dot products, matrices in machine learning. All the data may not be numerical. See, we have seen the data can be an image, it can be a video, it can be a numerical data or whatnot. So your data can be anything. It need not be always a numerical data when you are dealing it with. Say, for example, I showed you an example of a car, which is a convertible car in your previous slide. So there, come back to this example here. So here the data is not numerical, but it is an image. So this image has to be converted into a data which is understood by a computer. So if I just fed an image like this, the computer will not be able to understand. So you need to convert into a data which is understandable by the computer to process the data. So for that, you need statistics and linear algebra. So that is what I'm trying to tell. Since all the data is not numerical, it has to be appropriately converted into a numerical representation to be fed to a program. So the data are considered as vector. So data needs to be considered as vector. So I'll tell you, show you the appropriate slide here. So the data is always not numerical, and it has to be converted into a data set which is easily understandable by the computer program. That is why you need vector products, linear algebra, and statistics. Okay. Vector and tensor analysis are the heart of a machine learning. At least there are three ways where vector comes into picture. So now I'm dealing with vector analysis and tensor analysis and its importance in the machine learning. Why vector and tensor analysis is of importance? There are three ways where the vector comes into picture when we are modeling. Which can be dealt in more detail when we go into hands-on, as vector as an array of numbers. So vector is considered array of numbers. For example, you want to import numpy as an object np, where array is defined as 1 2 0. So next example is vector as an arrow with a magnitude and direction. So vector, as you know, has magnitude as well as direction. This is used to find clusters Euclidean distance. Vector as an object that obeys addition and scaling. So there are three ways in which vector comes into picture when we are modeling, and which is dealt in more detail when you are doing hands-on. So what three ways is, when vector is considered as an array of numbers, like array as 1 2 0, and vector as an arrow with magnitude and direction to find clusters, distance. Vector as an object that obeys addition and scaling. Example, this is applicable for very large data set. When you are dealing with very large data set, you have to use this vector as an object that obeys addition and scaling. The sample space need to be scaled down with all the varieties to implement the model for generalization. This is applicable for very large data set. In such data set, the sample space need to be scaled down. When we are scaling down the sample space, the sample should not be lost, or the information should not be lost. Scaling has to be done with some kind of logic, so that all the varieties and all the attributes which need to be scaled down are retained. So scaling down has to be done using some kind of logic to implement the model for generalization. This can be visualized when an actual car model is scaled down to a small scale to be manufactured as a toy. Like for example, Hot Wheels. See, you get Hot Wheels toy, where you get convertible car, all kinds of cars. So it will be exactly scaled down version of your actual car. So how we are able to scale down is, all the attributes which are present in your actual car are also present in your Hot Wheels car. So all the attributes are present, and only the sample space is scaled down with all the attributes being retained. So all the attributes are retained, and only sample space is scaled down. So vector as an object that obeys addition and scaling. So that is why vector analysis and TensorFlow is needed when we are scaling down large data or large data set. When we are taking, you scale down, but you retain all the attributes. So that is what is an example of Hot Wheels car, where the actual model of the car you can see, where you all the sizes from all the attributes, tire, engine size, texture, what all you can see, all is scaled down in the proportion it is needed to be scaled down. That is what I'm trying to tell you here. So that is for which you need to have this vector analysis and tensor analysis understanding. So I'm just showing you the appropriate slide in Spanish for you to understand. I hope it is clear. So vector for array of numbers and finding out the direction, and for the data space and how to do that, everything we are trying to understand in this particular slide. Next, the significance of statistics, vector algebra, scalar, dot product matrices in machine learning continued. Since the numerical data are also vectors, we represent them as matrices. Since the numerical data are also vectors, it is easier to represent as a matrix. The study of vectors and matrices are termed as linear algebra. The study of vector and matrices are termed as linear algebra. We need to quantify the prediction value of a particular test data. Probability comes into picture. So far we have understood the importance of vector and tensor analysis. Now need to quantify the prediction value of a particular test data. Probability comes into picture to quantify the prediction value. Fortunately, Python, scikit-learn, TensorFlow has proper packages to do all this mathematical work. So already you have this Python programming, scikit-learn, TensorFlow, which are already there as a package to do all this mathematical work. We also, all we need is to do is know this concept behind that, so that the proper package is imported and used. So already we have packages in Python, scikit-learn, and TensorFlow, which does this work of quantifying the prediction value of a particular test data and finding out the probability. For example, now again I'll go back to this slide here, or image of the convertible car. Here I can tell you the probability of this being an automobile is almost 100%. It being a convertible is 37%, and that being a cruiser is 37%. So these are the probabilities of this being a convertible and a cruiser, and automobile is 100%. So finding out these things, you already have these packages, Python, scikit-learn. So this is why probability comes into picture now. TensorFlow has packages to find out these probabilities. You should know which package to use when. So that is what I'm trying to tell in this particular slide. So I will show you the appropriate Spanish slide for you for better understanding. This is why probability is needed, and the Python, scikit-learn, and TensorFlow are used to find out this. Okay. Now we have understood why probability is needed and why vectors are needed, why matrices are needed. So all these mathematics are needed, and fortunately we have a lot of packages where we can use this as a ready-made package. We should know when to use and what to use, and to finding out the probability. Now we go to the types of machine learning or the ML systems. So you have under types of ML systems, you have supervised learning, unsupervised learning, semi-supervised learning, and reinforced learning. Supervised learning, types of ML systems, unsupervised learning, semi-supervised learning, and reinforced learning. So classification is based on the amount and type of supervision they get during training. So classification is based on the amount and type of supervision they get during training. So based on the training, so I can define as supervised learning, unsupervised learning, semi-supervised learning, and reinforced learning. Then you can also classify as batch learning and online learning. Another creation to classify the ML systems whether or not they can learn incrementally from a stream of incoming data. So batch learning or online learning means whether classify the ML systems whether they can learn incrementally from the stream of incoming data. So if there is an incoming data, from the incoming data, if there is a stream of incoming data, and if your machine learning algorithms can learn from that, then I can classify as a batch learning or online learning. So I'll show you the appropriate Spanish slide for this. Supervised learning, semi-supervised learning, reinforced learning, batch learning, and online learning. So this is what I'm trying to tell you in this particular slide. So batch of incoming data, if the machine learning algorithm is learned, then also that is known as batch learning or online learning based on the stream of the incoming data what you get. Otherwise, the machine learning algorithm, as we are seeing, semi-supervised, unsupervised, semi-supervised, and reinforced learning. So just to tell you again, I'll be doing that in detail. Supervised learning means somebody has to supervise that learning process. So that is why it is known as supervised learning. The next one is your unsupervised learning. So no supervision is required. The in between hybrid of these two is known as semi-supervised learning. Reinforced learning means that learning is always reinforced with new data set, known as the reinforced learning. And you also have batch and the online learning as part of the types of the machine learning algorithm. Okay. Okay. Then you also have a new classification which I can do, instance-based learning and model-based learning. The classification of the systems can be generalized of generalization of examples from the training data. The systems will be able to generalize from the example it has never seen before. So you have another subsystem known as instance-based learning and model-based learning. In this, classification of the systems can be based on generalization of the examples from the training data. Generalization of the examples taken from the training data. The system will be able to generalize from the examples it has never seen before. So from the examples from the training data, the system must be able to generalize the new data set without the examples it has never seen before. So that is what I am trying to tell you here. What I mean to tell is your instance-based and model-based learning, you are already training a data set with so many examples being fed. Now you suddenly give an example which is not in the previous data set, what you have already fed, but still your machine learning algorithm should be able to predict what is that data set. So that is what I'm trying to tell in your instance-based and model-based learning. Again, I'm telling for this, you need to have the knowledge of linear algebra, statistics, tensor analysis, all this mathematics will come into picture. So once you are very good in mathematics and little bit with Python programming, you can be very good in your and this machine learning. Nowadays, machine learning is coming everywhere. Maybe in your medical delivery of what to say, healthcare systems also will have in future machine learning. A patient will go. Now he has to go to a doctor. A doctor will analyze the patient. So he will ask whether you have fever, whether you have blood pressure, whether you have this problem, whether you have diabetes. So based on that, he will try to understand the patient's history, then his present problem, then he'll prescribe a medicine, or he will prescribe a various kind of test to be done. So all this can be done using machine learning also. Actually, this was also discussed. I can tell you, we have in India known as Indian Council of Medical Research, ICMR. So in India, we have a lot of remote locations wherein the healthcare delivery is very poor. So we have very modern cities like Bangalore, where I am staying, where we have excellent healthcare infrastructure. But if I go some 50 kilometers or 25 miles from this place, the healthcare infrastructure is very poor. So in these villages, there is no doctors available. So this machine learning algorithms can do the prediction. So it will ask the patient. So you can classify the data of patients based on age, whether he's male or female, whether he's having any diabetes or pre-morbid or comorbid conditions. So these kind of classifications can be fed to machine learning using the data set already we have. So the now the patient will go. So he has a particular fever or whatever it is. So the machine learning can predict, so what is his fever for? So it can predict the next course of test, at least do this test and then go to a doctor, or take this medicine and then do a test. So this preliminary screening at least can be done by a machine learning algorithm, so that healthcare delivery can be at least be semi-autonomous, if not fully autonomous. So what I'm trying to tell you is, in case of rural place where doctor availability is very less, or in very remote locations where you don't find doctors, So these kind of machine learning algorithms, if implemented, can really be a game changer in your healthcare systems, because the number of doctors are limited. Okay, now in this kind of pandemic situation, we are having shortage of doctors. See, actually, this was a policy matter raised in one of the discussions. You can increase the number of bed sizes, you can increase you can make hospitals, but you cannot make doctors overnight. Doctors are human beings, so they need to be trained for 4 years or 5 years along with 1 year of training, then only you become a doctor. So these kind of machine learnings can be implemented for the implementation of our healthcare delivery system, wherein progressing nations like India and even South American countries will get benefited because of that. So that is what I wish to tell. So this is the where the machine learning can go. So it has applications in every field. It also has applications in automobile field. So for example, now you are driving a car, you want to change the lane of the car, so you get indication whether to change lane or not. So another thing is your fatigue detection while driving. The driver is driving the car, so suddenly he falls asleep. So seeing the attributes, the image of the person, so that data set is fed. So a person is about to sleep. So if a person is about to sleep, an alarm will be sounded in the car. So with that alarm being sounded in the car, so you can wake up that person, and that can be done. So whether it is automobile engineering, whether it is healthcare delivery, whether it is what to say, prediction, so many things can be done using machine learning algorithms. And for more specific implementation, we need to go for deep learning algorithms. Okay, so I'll just touch upon supervised learning in today's session. Then I will break for today and open for a question answer, so that I can continue this in the next session, the remaining slides. Excellent. Supervised learning. So the first set of subset of learning which we are doing is the training data we feed to the algorithm includes desired solutions called labels. The training data set is fed as to the algorithm. So first, any algorithm, you need to train that algorithm, and which includes the desired solution. So solution to a problem also you are inputting to the algorithm, that is the data. So they are called as labels. Supervised learning tasks are basically classification. Supervised learning tasks are basically classification problem. Some regression algorithms can be used for classification, such as logistic regression. So once you are feeding a data set to algorithm, you need to, what kind of algorithm should be used? These are mathematical algorithms. So regression is the easiest algorithm or the most widely used mathematical algorithms, which is used for supervised learning in machine learning. So supervised learning algorithms in this discussed will be K nearest neighbor, linear regression, logistic regression, support vector machine, decision trees, and random forest and neural networks. So these are the various supervised learning algorithms which will be discussed as part of this course. So what is supervised learning? And the various mathematical algorithms that will be discussed as part of the supervised learning, that is K nearest neighbor, regression, support vector machine, linear regression, logistic regression, random trees and forests, and you have neural network. So these are the various algorithms that we are using for the supervised learning. And please remember, in the supervised learning, the data set what we are feeding and the expected output is also fed as a input and to the algorithm for the supervised learning. Okay, I think I can stop at this slide for today. About 1 hour I have spoken. So I am open for the question answer sessions. I will be continuing this in the next week.
Ok, Ulises, acaba de terminar la lecture y indica que está abierto para preguntas.
A ver, por favor, si tuvieran preguntas acerca de la presentación sobre introducción Machine Learning.
Good morning, Professor Narayan. An honor uh, to be here you today. My question is, what techniques can be used for data preprocessing?
Pardon?
Preprocessing the data. Preparing the data, pre-processing the data before applying a model. He's asking
Yes.
what techniques he can use on that state.
Any pre-processing the data. So how
Yes.
to pre-process the data. So actually I have just given the basic introduction towards the machine learning today. So basically in the next class I will be able to answer your question in a better way. Pre-processing the data is based on the what kind of data you are feeding. So whether that particular data needs a pre-processing or not is to be decided when you are designing the algorithms. When you are designing the algorithm, you have to decide whether the data needs to be pre-processed or not, or whether the algorithm is robust enough to take care of all kinds of data. So basically, when we are designing any kind of machine learning, it has to be robust enough to learn from the new example. So that is what I have shown in this particular slide. So I'll just come back here. So the classification of the systems is based on generalization of the examples from the training data. The systems will be able to generalize from the examples it has never seen before. So even if the data is not pre-processed, your machine learning algorithm should be able to predict any new data set or example. It has to give this one. So your machine learning algorithm should be robust enough. So basically the training set is what is very important. So you need to train the data set very much in detail. So I have my colleague here, Divya Shri. So she has also answered that question in the type box. So during the hands-on session, you'll be able to understand it better. But basically, the training needs to be very robust. So that is what I want to tell. So in that case, pre-processing will not be required.
Thanks.
Francis.
Hola, ¿puedo hacer una pregunta, Ulises?
Sí, adelante, por favor.
Hi, Mr. Narayan. Can you hear me well?
Yes, Mr.
I
Jose.
have a question about. Oh, thank you. I have a question about rapid miner tools like WEC, R-Tool, MIME. What's your opinion about these data analytics tools? And my second question is about instance-based models. It's usually these models are more accuracy than other models. But in your opinion, what is the best model to use in some kind of data? Thank you.
So if I have understood your question well, so already you have models like Rapid Miner, Veka and all. So Veka is more efficient tool to start with. For us, if you want to begin, so Veka is a better tool to start with. And your second question is about various models that we can use. So that it depends upon whether you are going for supervised or unsupervised learning, whether you are going for reinforced learning. What is your end application is what is to be understood here. So based on the end application, we can use the models or design the models appropriate to the needs of the application.
Okay, thank you.
Otra pregunta. ¿Alguien quisiera formularlo?
Yo puedo hacer una pregunta.
Oscar, no se te
Hola,
escucha bien.
¿puedo hacer una pregunta?
Sí, adelante, por favor.
¿Me escucha?
Sí, te escuchamos.
Ah, sí. Hi, Mr. Narayan. I have a question.
Hello. Yeah,
What is
hello,
the
Mr. Martin.
criteria? What is the rate and data testing?
I'm sorry, your voice got it is broken. So can you repeat?
Haz la pregunta de nuevo porque tu señal no estuvo buena, por favor, Oscar.
¿Puedes escribirla quizá? Hay una...
Ya, sí, quería preguntar
interrumpe
cuál
la-
era el criterio de 80-20. Hola, ¿me escuchan?
Sí, sí.
Hoy sí.
Néstor, translator.
Ok, Oscar, ¿cuál es la pregunta? El criterio 80-20 aplicado a...
¿Por qué? Sí, sí, ¿por qué se utiliza el 80-20? ¿Por qué es ese
Alright, he's curious about...
criterio y en qué escenarios, en qué casos de uso se ajusta ese 80-20 a un 70-30 o a un 90-10?
¿Te refieres a partición de data, Oscar?
Sí, debe ser.
Así es,
Ajá.
a cómo se reparte la data
Entrenamiento de datos.
para el
Entrenamiento de
training
datos.
y para el testing.
Doctor, he's curious about why sometimes we use 70%, 30% partition when we work with a data partition, sometimes 80-20 to train a model. So how can you decide where to use some partition or the other?
So that depends upon the size of the data set we are dealing with. So based on the size of the data set, the decision needs to be taken. So ideally it is 80% training and 20% testing is what we do.
No significa que depende del tamaño del dataset, ¿no? De la situación y del... Recomendable, como ha escrito ahí, es el 80-20.
Gracias.
Okay.
I have a question, Professor Narayan.
Yes.
What of the techniques suits better the genetic algorithms in working, for example, a design of a bone, for example? Do you understand
Can
the
you
question?
kindly repeat your question?
Yes, the question is in a project is design of a bone, okay, replace a bone, human bone. So that is working with genetic algorithms. So my question is, which one is the best technique that it can suit with using genetic algorithm for this case of project?
So you mean to know which algorithm to use in case of genetic algorithm?
Yes, yes.
So you are taking a bone as an example. So you want to classify the bone.
It's like a prosthesis replace.
So that depends whether you are dealing with images or numerical data. So if it is an image, then we have to deal with it separately. If it is a numerical data, we deal with it separately. Or if it is a combination of two, again, we have to deal with it separately. So if it is a numerical data, we can choose so many models for implementation. If you are dealing with image, then the difficulty level increases. I am not gone into detail with genetic algorithm to answer that particular question.
Okay, thanks.
¿Alguna otra pregunta más?
Sí, yo tengo una pregunta más.
A ver, José, adelante.
Mr. Narayan, I have
Yes.
what is the minimal amount of data to training a model? There is a rule for determining that.
Okay. So what you're, if
For
I
example,
understand your,
in a regression, for example, in a regression or in a decision tree, there is a rule to determine the minimal amount of data.
So your question is how do you define what is the amount of data you need to train the data set, whether there is some rule for it or what, for example, in a regression tree, that is what you are trying to ask. Did I get your question right?
Yes, but some
Yes.
researchers say that, for example, with 13, um 13 rows of data, it's okay. But I don't know if this is a rule.
So at least we need 20,000 entries of data set for training. So this is the general thing we take.
Okay, then there isn't a rule. It's only
Hola, buenas, ¿me escucha?
Otherwise, you cannot generalize the model. So model cannot be generalized, or you will not get a predictable result for that.
okay. Thank you, thank you.
Okay. Marcos,
Le
quería
quería
preguntar.
hacer una pregunta. Le quería hacer una pregunta. ¿Que en español o en inglés la pregunta?
Como gustes.
Por el momento, alguna convocatoria de trabajo. Soy técnico en computación, estuve estudiando ingeniería de sistemas y me retiré por motivos económicos. Y por eso.
Bueno.
¿Cuál es la pregunta?
Serían cuáles son las oportunidades de trabajo que se vienen en Perú con Machine Learning, ¿no?
Pardon, I didn't get your question.
Narayan,
They are talking about job opportunities, professional opportunities
Yes.
on this field. What
Okay.
would you say that are the best examples on developing nations like ours?
Yes. So thank you. I think this is the most relevant question is what are the job opportunities and the career growth available if we master machine learning and deep learning? So this is a very valid question. So as I told you, you find applications everywhere, whether it is in medical field or you are in automobile engineering or anything. So especially for developing nations like India and Peru, what we need to do is we lack the basic infrastructure facility, or there are some of the advanced facilities which the advanced countries don't have. So using machine learning, I gave an example of how a medical infrastructure can be improved and all the people can be benefited, because you can't increase the number of doctors. So for a better implementation of the better implementation of the medical facilities, how machine learning can do. So whether it is data science, so data science comes everywhere. So data is everywhere. So now you can see the amount of data we are dealing with. So it is quite huge. It is in megabyte and terabyte. So that is the kind of data we are dealing with. So machine learning finds application everywhere, whether it is automobile engineering, whether you are electrical engineer, whether you are computer science engineer, whether you are a medical professional, you will find applications. And I can assure you that after learning machine learning, you can be, not only be a university professor or a teacher. See, this has to be you can be an entrepreneur, you can be a first generation entrepreneur, you can start an industry, you can give services to others. So that is the kind of thing we are looking at in machine learning. So it has a tremendous scope.
Thank you very much. I have another question. First, thank you for sharing your knowledge here with us. And second, my question is about financial applications. With all these kind of models on this field, what would you say are the main examples of financial applications, stock market applications, in regards to this machine learning or artificial intelligence in general, deep learning
Okay,
even?
this is one of my favorite subject because I also follow stock markets very closely. So, very good question, and thank you for your question. So now, I think many of you would have been following stock markets. So in financial markets, it is very difficult to predict what your market is going to do or a particular stock price is headed towards. So we are using many tools already, which was not used earlier, such as moving averages, relative strength index, and so many other tools we are trying to use in the stock markets. So recently, this machine learning algorithms prediction for stock market has recently started. But there's not much data which we can do. So we are doing will be the pioneers in that. So if you can predict the stock price using machine learning algorithm, already my team has taken that as a or some kind of project. So we are trying to work on some kind of machine learning algorithms for prediction of stock prices. Because if that is done, that will help a lot of investors to take a decision to whether to invest in a stock or not. So this comes under as a part of technical analysis. As you know, stock market has technical analysis and fundamental analysis. So in fundamental analysis, we go into the fundamentals of the company or the stock we are investing. So machine learning can become a part of technical analysis to predict the stock price. So this is a good suggestion, and models need to be generated. So far, there has been a reasonable success in limited people who are working on this. So yeah, there's a lot of scope for that.
I have a question.
Thank you.
Dr. Naraya. Thank you for having you here. It's an honor. My question is, if we have a problem or regression or classification, what algorithm we should use in those kind of problems? How you define the algorithms in each case?
You mean to say which algorithm to select? Or?
How do we select the algorithm in a problem of regression or classification?
Okay. So if the data is, again, it depends upon whether you're going for supervised or unsupervised learning. So far, you have just touched upon supervised learning. If the data is a continuous stream of data, then we go for regression. So depending upon the data set, the algorithm is chosen. So if you have a continuous stream of data, then we go for linear regression, that is the or logistic regression, that is the very simplest form of machine learning algorithm to be used. So if you have more complex data, then we go for different algorithms. For discontinuous, we convert into classes, then go for regression. Otherwise, you go for classification.
Okay, thank you.
Tema me pareció muy interesante, bonito tema. ¿Cuándo se vuelve a dar otro tema?
Ernesto, tengo una pregunta, ¿es posible?
Sí, claro.
Ok, ¿cómo estás, Ernesto? Discúlpame. Bueno, mejor lo hablo en español porque el inglés no soy bueno con hablarlo, ¿no? Entonces, bueno, mi pregunta es la siguiente. Primeramente, por favor, traslada mis felicitaciones, Ernesto, al doctor Narayan, ¿no? Por su excelente exposición, ¿no? Y el agradecimiento de antemano, ¿no? Mi pregunta es la siguiente, ¿no? La función de activación, ¿no? Es clave para los resultados de una arquitectura en redes neuronales a través del descenso del gradiente, ¿no? Como es en el caso de las redes convolucionales. El ReLU, que es utilizado en diferentes patrones como el AlexNet o el GoogleNet, ¿no? Y que se aprovecha en un framework que es el ResNet, ¿no? Mi pregunta es, ¿cómo lograr, digamos, una mejor estrategia para optimizar el aprendizaje cuando las redes se hacen más profundas, o que tengan más capas de profundidad, ¿no?
Okay. So first, he's thanking you for your presence here, and second, he's asking about the activation function. How is this key on neural networks? So the question is how to find a better strategy to optimize the modeling when you have many layers on a neural network. In regards to activation function, in regards to this context where you have um, a problem with you're applying many layers on it. What criteria to have in consideration for activation function?
I didn't get your question, Penny. Please repeat.
Right. So, Sergio, es sobre cómo encontrar la mejor estrategia para.
Te lo escribo por el chat, ¿ya? Para que quede mejor. No, te lo pongo acá en el chat en este momento. Ahí está. Lo pongo en inglés de repente para que el doctor lo lea.
So he's
Está en inglés.
talking about the function of activation on the results for architecture of with neural networks using gradient descent. Okay.
So I just read out the question. I have the activation function is due to the results of an architecture in a neural network through gradient descent. Okay. In case of convolution neural network, the ReLU is used in different patterns such as AlexNet or GoogleNet, in patterns such as RenSet. How to achieve better strategy to optimize the learning networks when networks using in greater depth. So you have to use kernel optimizations in order to optimize for a greater depth. So that is the answer for that.
Basically, yes. Thank you very much.
Francis González creo que está levantando la mano, quiere participar.
Sí.
Yes, hello. Good morning from this side. Francis Gonzalez. Dr. Narayan, what do you think about auto machine learning models? Okay, the ones that are, for example, offering Google or H2O. So you don't select anything, you just give them the data, what is the result that you want to get, and they do everything like magic. Okay, what do you think about those models? Because I think it's like a trend right now because a lot of people are using it, but they don't know what is behind those auto ML models. What do you think about that?
Yeah, good question. Okay, so what is your question is Google and Amazon are already using many machine learning models. So what is your view on that? See, for example, you are buying something on Amazon. So next time you are opening Amazon, it is going to prompt you into buying something based on the previous experience of your purchase in that. So that is the kind of machine learning algorithms they have implemented. So already they have some machine learning algorithms which are being fed to this Google and Amazon. So they are continuously working on, their technical team will keep on working on to improve the customer preferences and other things. So what they are actually implementing, nobody knows. But they're really minting money out of it. That is what we can understand, because they were not going to tell what exactly they are using. But if we were to use that, again, you can become an entrepreneur. So that is the brief answer to your question.
Yeah, great. Thank you.
I have a question, Professor Narayan.
Yes.
We know that you have some expertise on optical and photonic. So how you relate this the photonic and the optical with the machine learning? What are the techniques most used, and what are the results in this moment with your research actually?
Yeah. Thank you for your question, Professor Zero. Actually, my research area is in photonic integrated circuits and lab-on-chip sensor systems. And recently, I started learning on this machine learning, and I thank you for the invitation where I delivered a talk on machine learning. Usually, I give talk on photonics, optical integrated circuits, and so on and so forth. So the problem I encountered during I work on lab on chip sensor systems. So in lab on chip sensor systems, what is my thing is you give a blood droplet, I should be able to tell you what disease you can have or what illness you can get. So that can be done using machine learning. So machine learning should be part of my lab on a chip sensor system. So if you give a blood sample or any sample I take of human being, any human physiological sample, I should be able to predict whether that person will get a disease, whether he will get cancer, whether he will get diabetes, or he is healthy or will he remain healthy. So today I am healthy, tomorrow I am healthy or not is a prediction that nobody, including myself, I may be able to make. So if that machine learning is able to do, so that is how I am able to use the data from photonics and implement machine learning algorithms. See, we have optical detection of human physiological fluid. So through optical detection of human physiological fluid, through refractive index changes, I can predict some diseases. If I implement machine learning, my model will be more robust. So that is how machine learning comes into picture. Okay, if everyone agree, can we continue the next week?
Okay, si estamos de acuerdo, va a continuar la próxima semana. O sea, está en tiempo ya. Okay,
I think Zero, he has given very wonderful talk. I was also listening, Professor Narayan. So now I must be tired. So much he has given very nice talk. So next week he can continue.
So, Ulises ya se está retirando. ¿Alguna palabra final?
Sí, agradecer por la presentación y también comunicarlo a los participantes, a todos los participantes, que ya está disponible en el aula Classroom la información, tanto en inglés y en castellano del curso. Y también hay materiales, por lo que le vamos a enviar a través del correo.
Okay. Thank you very much, Professor Narayan and Professor we are very glad to have you today. It's an excellent lecture, and we hope continue with this next week. Thank you very much again. We are very happy to have you.
And I'm having a very excellent audience and a lot of questions being asked. Thank you very much. It was a very enlightening experience. And thank you, Professor Zero. Thank you, Professor Noporto. Thank you for all the audience who have asked me questions. Thank you, Dr. Preeta Sharan. Thank you very much.
Thank you. Thank you. Very nice presentation. Very nice. Thank you.
Thank you.
So we'll meet next week again. Okay.
Okay. Nos vemos la próxima semana.
Good night, Zero.
Good night, Professor Narayan. Good night, Professor Preeta Sharan. Nos vemos la próxima semana.
Nos vemos la próxima semana.
Los ejercicios, hay un ejercicio de Python de Titanic que se está compartiendo, también las diapositivas. Okay. Entonces la próxima semana a las 9 en punto nuevamente de la mañana continuamos con las clases. Thank you very much. Bye. Bye.
Yeah, bye. Thank you.
Thank you very much.
Thank you very much. Thank you very much to everybody.
Thank you.
Thanks a lot.
Thank you. Thank you.
Thank you for the presentation, Dr. Narayan.
Thank you very much for the class.
Bye bye, everyone.